This meeting is being recorded.
In this video, we're going to look at how pH can affect our solubility of slightly soluble salts. So we should note that the solubility of an ionic solute can greatly be affected by pH because an acid-base reaction will be occurring as the salt dissolves. So say we have a substance that has a basic anion, and I have a couple examples drawn out down here that show that. It's going to be more soluble, so increase in solubility in acidic solutions. And this is because in acidic solutions, there's an excess of hydrogen ions available um, to interact with, in this case over here, with the basic anion hydroxide. So we have hydroxide here. If we're in acidic solution, we in essence will remove some of that product, that OH, to form the stable liquid water here. So we're going to shift to the right, and overall we'll increase the solubility of our salt by doing so. So it's like you're removing product and we're just invoking the rules of the Le Chatelier principle. So let's see here, we have another salt. It dissolves in water. If we're in acidic solution now, this anion here, the fluoride ion, will interact with H+, and instead of forming water now, we're going to form a weak acid, which is also fairly stable. So we're going to again shift to the right, increase the solubility of our salt, because we need to reach that equilibrium again to since we removed it with the creation of this weak acid, we need to replace that F negative product. So let's take a look in sample exercise 15 here and see if we can determine which of these salts would be more soluble in acidic solution than in basic solution. So we're going to be looking again for a shift to the right. Towards products, we're going to check for would we have a removal of product. And by that, we're going to say due to formation of what we saw above, H2O, or a weak acid. So let's see what happens. If we were to dissolve nickel in water, we're going to get nickel 2 ions, and then we'll get 2 hydroxide ions. So when this happens, the hydroxide, if we're in acidic conditions, acidic solution, we'll get liquid water, so we'll say yes. This is more soluble in acidic. Let's look at our barium fluoride here. So we ionize this, we dissolve it in water, we get barium and fluoride ions. Just like we saw above, that fluoride will interact with that H+. We'll get HF, a weak acid. So again, we'll say yes. Barium fluoride is also, just like the nickel hydroxide, more soluble in acidic solution. So let's check our calcium carbonate here. So we get calcium, we get carbonate ions, one of each. And now we're going to dissolve this in water. I'm sorry, we've already dissolved it in water, but now if we add to the CO3 specifically some H+, actually 2 of those we'll need, we can form carbonic acid, and this is again a weak acid, so once again we'll say yes. In this last case here, we're going to have both silver and chloride ions, and if we were to take this chloride ion, and then we'll add that to our H+ here, we would get a strong acid, HCl. So this would just dissociate or ionize again. So we would actually see a shift back towards our salt. So this would have a left shift, and this we would say no.